about 20 seconds, I'm going to ask your attention to finish up. All right, I'm going to ask your attention right now, if you don't mind. The last two things I want to talk about today, the second day of your review out of 3, is to be quickly springs and pendulums. So here is a pendulum. Can you please try to remember the two major things that affect the time it takes to go back and forth? What two things could you change about this to affect the time it takes to go back and forth? Talk. There's two major things and one kind of maybe thing.
Height, length, and
Yeah. Over G.
yeah. Height and length. And then
Ethan, think you have one?
Yeah.
What is it?
Length.
The length of the string, fantastic, is one of the two major things. What's the other major thing?
height.
Gravity, not height.
Oh,
Now, there's something else that kind of makes an impact, and that's the angle we said. Because if you go at too high an angle, it'll
oh,
drop
yeah,
before it
yeah.
swings.
That's like a question.
So usually we just say it's a small angle. Well, those are the two things. Mathematically, we said that the period, or capital T, is 2 pi square root L over G. That's the time to go back and forth. Look at these 2 points right here, A and B. Can you please remember which of those 2 points has the most restoring force? 30 seconds, go. Which of those 2 points have the most restoring force?
Mark. And then these equilibrium with velocity. Still remember from second quarter. Wait, this was second quarter or third quarter?
And here we are. That point
Second
is
and
definitely going to be point A. It's got the maximum force. Can you please now tell me which point or points has the most velocity? Which point or points has the most acceleration? Go.
Equilibrium.
Which point or points has the most acceleration, most velocity? Andy, you're thinking too, okay?
Acceleration is point A.
Rod, you're thinking and talking too, okay?
Yeah, acceleration, equilibrium, and
Yeah, it's force, is acceleration, and then equilibrium is velocity.
And they're two separate points.
Whoa.
The point with the most speed is going to be here at equilibrium, because that's where it's the lowest and we're going the fastest. The point where it has the most acceleration is point A, because it has the most force. Then I talked about springs, where we had, for example, x, the distance from equilibrium. I remember that. Please remind me the two things that affect the time for a spring to go back and forth.
The restoring force, and then the distance.
No, there's two variables.
the period equation.
L over, it's L over M. Wait, yeah.
L over there.
Oh, it's M over.
Or M over L.
So it's mass.
L over M.
In this case,
Hey, wait,
mass does matter. K over M. K is the spring constant, M is the mass on the spring. Is that okay?
Yeah, it's M over
Yeah.
L.
I always forget that.
Mortal Kombat song.
It's on your phone
Yeah, I just say
machine.
Muhammad's cases. I remember.
Yeah. And in physics, there's one that's reversed. Okay. Please remind me, which point, A or B, is going to have the most restoring force? When it's away from equilibrium or at equilibrium? And the answer is definitely away from equilibrium. And mathematically, there's an equation there. Negative kx. So what I focused with you on this stuff is I focused on finding the periods, what affects the periods, and kind of like where's the restoring force the most? Where is it going the fastest? Where is it going the slowest? That kind of stuff. Can you please try, I think questions 10, 11, 12, with some spring and